Our mission is to help students achieve academic and professional success.
We will guide you step by step with high-quality learning resources and practical problem solving.
Students, today we will solve GATE 3 marks question. 100% guaranteed 3 marks will come in your GATE, as well as this is very good for the placement and semester end exam. 5 marks will come in your semester end exam. Now, today we are talking about the number system. Now you can see this is a dot. Okay, this dot is the fixed point, number first. So from this dot means decimal, this is the fraction point, and this one is the integral part. If you know the binary system, today we will discuss more about the binary system, hexadecimal, decimal, complement. Okay, so we will discuss about the sign magnitude. Number first we will discuss about the first complement, we will discuss about the second complement, why the second complement came. Now we are starting from here. Number first we will try to explain the fixed point. What is the fixed point actually? The fixed point is the position of the decimal or binary point. It is the fixed. Okay, it is the decimal or binary point, that is the fixed. So what is the meaning of this? If you have a number 26.26, number first is what is the base? This is important. Number first, what is the base? This is a decimal. This base represent the number. What is the number actually? And this dot represent the fixed point. Getting our point? So there is a two parts. One is the integral part and second is the fractional part. So we are discussing about the sign magnitude. In the sign magnitude, we will discuss about the MSB. Okay, we will show one by one all the example. So now first, this is the first representation, data representation. So there are two number, first is the magnitude and second is the complement. So in the magnitude there is a unsigned and signed, and in the complement there is first complement and second complement. The representation of positive number is always same. Only representation of negative number we will discuss. Now we are just talking about this one example, so easily you will understand what we want to say. Suppose you have a number. This is a number. Suppose I want to write, suppose what is this? 0, 1, 2. Okay, so this is 0 means 2 ki power, this is 2 ki power 0 in the binary form. Okay, this is 2 ki power 1 and this is 2 ki power 2. 2 to the 4 plus 2, 6, and this 2 ki power 0 is equal to 1, but it is multiplying to 0. So what is the meaning of this? You will 0 multiply 2 ki power 0, then you will add 1 into 2 ki power 1, then you will add 1 into 2 ki power 2. So what is the final answer? Your final answer is 6 actually. Okay, your answer is 6. Now question is, this 6, what is this 6? This is a positive number or negative number? So this box, okay, it will decide this is a positive number or negative number. So this, you can see this number from here to here, this is also 6, and this number from here to here, this is also 6. But because of this last bit MSB, if I am writing 1 here, that is indicating this is the -6. This is the -6. This is the sign. Okay, this is the sign. And if it is 0, this is indicating this is +6. So what is the meaning of this? This number is +6 and this number is -6 because of this number, this single bit MSB. So MSB is indicating it is a positive number or negative number. And what is the meaning of this? The first bit representing the sign and the remaining bit are representing the magnitude. So magnitude always give you the same number everywhere. Okay, so here this is a 4-bit representation. What is the range? So in range, -2 की power n -1 to plus 2 की power n minus 1 minus 1. Now what is this? I will explain. Now see here, this is a very simple floating point representation. We will discuss about the 2 complement, we will discuss about sign magnitude, we will discuss about 1 complement. At first I will show something. Now see here, this from here to here, from here to here, you can see your first bit, your first bit, you see here, your first bit. Every time your first bit is 0, 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 your first bit is 0. But the remaining bit is the magnitude. 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 Remaining bit is the magnitude. First bit is representing the sign. Because of this 0, I am writing here plus. Every time you can see I am writing plus because of this 0. So because of the first MSB I am writing plus, you have to remember, and the magnitude is representing the number. Actually, what is the number? This number is based on the magnitude. Getting? If you understand what we want to say, now we will go here in the next page. In this next page you can see I am writing from 8 to 15. So you can see here last 3 bits are 0. Because of these 3 bits the number is 0, and the first bit is representing minus. You can see every time I have written minus. Why? Because your first MSB is 1. Every time your first MSB is 1. If you are not able to understand, again I will show you. Your first bit is 1, 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 your MSB is 1. If your MSB is 1, so this is the minus and the remaining is the magnitude. Understand? Okay. So now I will show one thing. See here, in the previous 2 magnitude I am writing 0 here. 2 magnitude I am writing here 0. I am not writing plus 0 or minus 0. But you can see in sign magnitude I am writing plus 0, and 1 complement I am writing plus 0. So here I am writing plus 0, here I am writing plus 0. Before 0, if you are indicating plus, means this is wrong. Why? Because 0 has no dimension. You have to remember, 0 has no dimension. If you are going to the next page, again if you can see in the next page, again 0 is coming second time, and this time I am writing minus 0, and 0 is coming second time. This time again I am writing minus 0. So one time you are writing plus 0 and second time you are writing minus 0 in 1 complement as well as in sign magnitude. But in 0, 2 complement you can see 0 is coming only one time. 0 is coming only one time, you can see. So because of this 0 is coming only one time, I am not writing plus 0 or minus 0 in 2 complement. So what is the meaning of this? In this representation there is a error. In this representation there is a error. There is no error, so 2 complement is the best. So the scientists, they discovered it, and every time we will discuss only about the 2 complement and we will use it. Now I will show something special. So now you can see we have a number. So this number, this is the first complement. First complement you have a 6 plus 6 number. Okay, you have plus 6. This is plus 6. You can check also binary number. 0 into this is 2 की power 0, and this is plus into 2 की power 1, and ये into 2 की power 2. Okay, so this number is indicating this is 6. Because of this 0 it is plus 6. Now this is plus 6. So what is plus 6? Your 0, 1, 1, 0. This is the magnitude, this is the sign. If you understand, this is the magnitude, this is the sign. If you are finding the complement, 1 complement, so what you will write? You will change the signal from 0 to 1, 1 to 0, 1 to 0, 0 to 1. So this is the 1 complement, meaning of 1 complement. But 1 complement is useless. Already we discussed why. Okay, so we are going to the second complement. So now what is the second complement? You can see again same number, this is plus 6, okay, and this 0 is indicating this is plus 6, okay. Now at first I will write its complement. 0 complement is 1 and 1 complement is 0 and 1 complement is 0 and 0 complement is 1. So this is 1 complement. After then I am adding plus 1. So 1 plus 1 is equal to 0, carry 1 here. 1 plus 0 is equal to 1 and remaining are same. So this is the second complement. This is the second complement for this is the second complement. This is the second complement for plus 6. Getting? This is the second complement. This is the plus 6. This is the second complement for plus 6. I think that you understand. So second complement, if I am going here, you can see what is 6. You can see what is 6. So my 6 was 0 1 1 0. It was my plus 6. In 2 complement it is plus 6. Okay. Now I will go next page. So now what is my 2 complement? Minus 6. You see here my minus 6 is this. My minus 6 is this and complement is 1 0 1 0. Okay. This is the 1 0 1 0 is minus 6 in 2 complement. In 2 complement 1 0 1 0. Now you can see this is also 1 0 1 0. This is also 1 0 1 0. So I have written plus 6 in 2 complement is minus 6. What is the number? Number is this. I think that you understand what is the meaning of plus 6 and what is the meaning of minus 6 and why we are learning the second complement, because we are writing the 0 only one time, but in other we are representing the 0 2 times. So we discuss about the sign magnitude, we discuss about the first complement, we discuss about the second complement. So similarly you can also represent all the number one by one, okay, from decimal to binary, and this is a range. Range for the sign magnitude is same and one complement is same, but in second complement the range only one difference. Here you will not subtract minus 1. So formula is same, minus 2 की power n minus 1, okay, 2. Okay, here I am not writing minus 1. Here I am not writing minus 1, and this is also same, plus 2 की power n minus 1 minus 1. Okay, so this is the second complement range. This is the second. Now what is the meaning of range? Again I will explain what is the meaning of range. So I will show you what is the meaning of range. So here we have a space. So range means, suppose I am writing 2 की power n minus 1, okay, minus 1, 2. I am writing plus 2 की power n minus 1 minus 1. Suppose your n is equal to 4. Suppose your n is equal to 4. It means that 4 minus 1 is equal to 3. 2 to the 4 to the 8. 8 minus 1 is equal to 7. So minus 7 to plus 7. This is your range for sign bit. Now I will check I am correct or not. This is the meaning of range. Now see here, I am going here. Where I am going? I am going here. In sign magnitude I am going here. Now you can see plus 7 from 0 to plus 7 in sign magnitude. Okay, plus 7. I am going next page. Now you can see again in sign magnitude my maximum value is equal to minus 7. So my range is plus 7 to minus 7. But here my range is minus 8 is max. Minus 8 is max. My range is minus 8 to 7 plus 7 in 2 complement, minus 8 to plus 7, because the formula we changed, minus 2 की power n minus 1 2 plus 2 की power n minus 1 minus 1. Okay, so the maximum value is plus 8. Okay, so now we are going to the next topic. So I think that you understand this is the second complement representation. So the first one is indicating the sign bit, and the remaining is indicating the integral part, and remaining is this is representing the fractional part. So suppose we are talking about a number, the number is minus 43.625. So the last 0.625 is representing the fractional part, and 43 representing the integral part, and minus is representing this sign. You You understand? This is the floating point representation of any decimal number. Okay, now I will go. So we already discussed about the decimal number system. We expect also decimal. So this dot, okay, this dot is the radix point. This dot is the radix point or decimal point. So if you are going from here to here, so your base power minus 1, base power minus 1, base power minus 2, base power minus 3. If you are going from here to here, your base power 0 at first, 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3, you will multiply. Okay. Similarly, in the binary number, this is your fixed point. If you are going your base power minus 1, base power minus 2, base power minus 3, and similarly here base power 0, base power 1, base power 2, base power 3. You will multiply each bit. Getting? Now see here, I have one example. If you are not able to understand, suppose you have example, your number is 101.101. So how to solve this problem? So what we are doing, this first bit we are multiplying with 2 की power 0 plus second bit we are multiplying with 2 की power 1, third bit we are multiplying with 2 की power 2. You got the first number, that is 4 plus 1. Okay, then after this decimal fixed point, we are multiplying 1 into 2 की power minus 1 plus 0 into 2 की power minus 2, then plus 1 into 2 की power minus 3. So you will solve the formula, this value, then after then you are getting your value is equal to 5.625. Base 10 is this now, because we convert this binary to decimal. Now how to convert this decimal to binary? You have a number 0.625. okay, you have a number 0.625. so what we are doing, every time we have to multiply this 0.625 into 2. So the first bit before decimal, first bit I will write here. Okay, again the remaining value I will multiply with 2 until I am not reaching 0. You will multiply by 2 and you are taking the first bit. All the first bit you are writing here, and top to bottom the representation is called the binary representation of this decimal. So this is a way to convert the decimal to binary. Okay, now we are going another one. Another one is the floating point representation. What is the meaning of floating point representation? Suppose we have written 5.625 number and the base is 10. Now we convert at first this binary number to decimal number. You can also check 101. Okay, so what you will write, this number you will multiply with 2 की power 0, this you will multiply with 2 की power 1, and this will you multiply with 2 की power 0, 2 की power 1, 2 की power 2, 2 की power 2, 2 to 4 into 1, 4 plus 1 is equal to 5. So this number is 5.625. This is 101 is 625. So now the number, this number, okay, this 3 is representing the radix point, means the decimal is present after the first MSB, means the decimal is present at the third place. The decimal, if you are not able to understand, I will show. The decimal this decimal is present after 3 bits of first MSB, your MSB after. Okay, so your MSB is here, this is your MSB 1, and after the third place your radix point is available, meaning is this. Okay, so radix point is present after the third bit from MSB, or you can say. Now we have a number, easily you will understand what is the floating point representation. Now here I will show one example. So again we have a number, same number 5.625. We have a number 5.625. I convert the number in binary decimal. Okay, in decimal to binary, 101.101. Base is 2. So this number 5.625. So after this 0, after this 0, okay, dot I have written 0.625, 0.5625, okay, I have written this number. After then I multiply whenever the dot is coming before, so I will write the power is increasing. If it will go to the left side, power is increasing, right side power is decreasing. So this is number, decimal number, so I am writing 10 to the power 1. So this power 10 to the power 1 is the exponent, and after decimal the numbers are the mantissa. Suppose we have a number, the number is in binary form, here also same representation. In the binary form, again I will push this dot at the first place, okay. So this is a mantissa. If the dot is coming, decimal is coming, or radix point is coming to the front, means to the left side, so your power will increase. So 2 ki power 3, your 3 is representing the exponent, and this after decimal the total number of bits representing the mantissa. So your first bit is the sign, and after then total, this is the exponent, and after then this is the mantissa, okay. Exponent means power and mantissa means after decimal total number of bits. If you understand, not understand, again I will show you how to solve the problem. So now if we are representing like this, I will show you something special. Now you can see, you can think, okay, we can place this decimal radix point any place where we should represent, where we should push the decimal point, okay, where we should place the decimal point. Suppose a person is placing at this place 0.101101. In this condition your exponent is 2 ki power 3. Suppose a person is placing after first bit, then your exponent is 2 ki power 2. Suppose a person is placing before 0.01 like this, then your exponent is 2 ki power 4. Suppose a person is removing the dots, in this condition your representation is, means your exponent is 2 ki power minus 3. If the dot is, means a fixed point is coming to the right side, power will decrease. If it is going to the left side, your power will increase. So now there is no standard form, meaning is there is no standard form a person can write in different form, means there are infinite ways to represent a number. So this is wrong. So the scientists they discovered, they have given you two standard form. So what is the two standard form? The first standard form is the explicit, and second is the implicit. What is the meaning of explicit? What is the meaning of implicit? Explicit means outside, implicit means inside, after one bit. Now you can see you have a number 101.101, same 5.625 number, and what we are doing, all the bits, before all the bits I am placing this radix, okay, before all the points I am placing the, you can see, before all the bits I am placing the dots here, okay. So means the dot radix point is placed at here, at this position. So this is a meaning of explicit normalization. Explicit normalization means how many bits they have given you. Just before, if you are placing the dot, means radix point, that is the meaning of explicit representation. Implicit representation means after first bit, if you are placing the radix point, that is the meaning of implicit representation, okay. So there are two types. One is implicit means inside after first bit, explicit means outside before all bits, getting? So this is the meaning of implicit and explicit. Now question is, which one is the best? What method we should use? I should use explicit or implicit? We will discuss now. Before, I will tell you one thing. Now you can see these are the numbers from -8 to 7. This is the second complement. I told that second complement is the best, okay. So now I am adding this +8. I am adding this +8 everywhere. So that is the meaning of bias. What is the meaning of bias? Bias means a max number. If you see in our previous my second complement representation was minus 2 की power n minus 1 2 plus 2 की power n minus 1 minus 1. If you write 4 minus 1 is equal to 3, 2 to the 4 to the 8, minus 8 is the max. So maximum value is plus 8. You will write plus 8, okay, not minus 8. So max is plus 8. Okay, in this range, my max is plus 8. Already we told at that time. So if you are adding this plus 8 everywhere from minus 8 to 7, this is the minus 8 to 7 second complement, range minus 8 to 7. Okay, you can check also here. Range you can check. Place here n is equal to 3, then you will get the answer. So after then, if you are adding, we are getting all the decimal numbers from 0 to 15, all range. Okay. Now we are going to the explicit and implicit representation. We will discuss which one is the best. Now you can see here, I am writing this number here. I have a number 5.625. At first I convert this number to the binary form 101.101. And after then this number I am using the explicit, so the dot will come here. Okay, dot will come here. So 2 to the power 3. Okay, so exponent is 2 to the power 3. Your sign is 0. Why? Because the number is positive. Sign is 0. Exponent is 3. Exponent is 3. Exponent is 3. I am adding plus 8. Why? Because the maximum bias is 8. Bias is 8. So 3 plus 8 is equal to 11, and I am converting the 11 is 1010 in binary form. Now mantissa means after decimal whatever the value, it is the mantissa. Now you can see, later we will discuss why I am writing total number of bits here. So now see here, suppose total number of bits are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total bits are 10. Okay, later we will discuss why there is a 10. So total bits are 10 from here to here. So the first bit is representing the sign, and after then your exponent means 11, 1011. This 1011 I place here. This is the exponent, and the remaining part is the mantissa. Mantissa is 101101. I am writing here 1011 1011. This number mantissa from here to here. Mantissa from here to here. So your mantissa is from here to here. Total number of bits in mantissa 1, 2, 3, 4, 5. 10110. 10110. I lost one bit. You can see. Same number if I am writing in implicit or normalization. Now see here 101.101. So 1.01101 to the power 2. Okay. After first bit, place the fixed point. So your sign is 0. Okay. And E means exponent is equal to 2 plus bias, because this power is 2. Power is 2 plus bias. This is 10. 10 I convert to the binary number 1010. 10 I convert to the binary number 1010. If you are not able to see, you can see here. 1010. Now you can see, I think that it is visual. So now this number is E 2 plus 8. 2 means this exponent is 2 plus bias is 8. Why I told this is the excess maximum number. So this is 10. 10 I convert to the binary number 1010. This 1010 I am placing here. Where? Here. I am placing here. This is your exponent. This is your exponent. And remaining part is the mantissa. Mantissa means after decimal. After decimal, this is your mantissa. Mantissa is 01101. 01101. Now you can see I placed all the bits after my decimal in implicit. So what is the meaning of this? My implicit is better than explicit. My implicit is better than explicit. I will go here again. I will solve the same problem. Same problem again I am solving. So you will understand. So at first I am coming here. Same number. I have a number is 5.625. I convert this number to the binary form 101.101. This number I am writing the explicit form. So it will come outside from this all bits 0.101, 101. Your exponent is 2 की power 3. Okay. So your output is this. As I am placing this, all dots are here, mantissa, and power this 3 I am placing here. From here to here I am placing. This already be done. Suppose we want to convert this number to again same number. This is your floating point representation. What is the formula? Formula is -1 की power s into 0.m. m means mantissa into 2 into e minus bias. Now question is why I am subtracting the bias? Because previous I add the bias. Now I will subtract the bias to reach the same destination. I am writing -1 की power 0. Why 0? Because this is a positive number. After then 0 dot I have the mantissa. My mantissa is 10110. 10110 into 2 minus 11 minus 8. What is 11? My exponent is 11. My exponent is 11. You can check. 1011 is 11. So 11 minus 8. 11 minus 8 is equal to 2 की power 3. This is 2 की power 3. So if you will solve this number, you will get 5.5. You will get 5.5. This is my final output of this representation, floating point representation. Again same. If I am using the implicit, so my formula is -1 की power s 1 dot mantissa into 2 power e minus bias. Again -1 की power 0. Why? Because 0 is the positive number. Because this number is the positive number 5.625. After then 1 dot mantissa. You can see my mantissa is 01101. This is my mantissa. This is my mantissa. So I am placing the mantissa here and 2 into e minus bias. What is e? E means exponent. 1010 is 10. You can check. So 10 minus bias. Bias is 8. Okay. So I got my value 5.625. So what is the meaning of this? If I am using the explicit normalization, then I am using my 1 bit, and this is the this output is not correct. Means after converting any number to the floating point representation, and after then floating point to same number, we are not getting the same number. What is the meaning of this? Because we are losing 1 bit in explicit floating point representation, explicit this normalization, and but in implicit normalization I am not losing any bit, so I am getting the exact answer. So what is the answer? My implicit is better than explicit. Remember it. This is very important for your interview. Okay. So I think that you understand up to this why we are using the second complement, why we are using the implicit normalization, why implicit normalization is better than other. Okay. So everything we discuss. Okay. Now we will solve some problem so easily you will understand what we want to say. So this is a gate question. I will solve today many gate questions all over all the previous year questions one by one. Suppose a person has given you this question 7.5. Okay. Base is 10. At first you will convert the number to the binary binary form. So this is 111.1 base 2. Okay, binary form. At first I am writing this is in implicit form. Why implicit form? Already I told implicit is better than explicit. So after the first bit I will place the fixed point. So 1.111 into 2 की power 2. So my exponent is 2 की power 2. So I am adding 2 plus 64. Now question is why I am adding 64? Because already he has given us that this is excess 64. What is the meaning of excess 64? Excess 64 means the bias is 64 here. So I will add the bias 2 plus 64. This is 66. So this 66 I will convert to the binary form, and I have written all the binary form here. Okay, so this is your 6. If you will calculate this number exponent, this is 66. You can check also. Okay, and after the dot I have 111. So this 111 I am writing here. After then you know that after decimal you can place infinite zero also, no problem. So this is your mantissa done. Another question they have asked you, write the floating point representation of minus 16.125 base 10. Okay, so the first question he has given you minus. So whenever he has given you minus means your sign bit you will write 1. Done. Second, you will convert this 16.125 to the binary form. Already we discussed how to convert the decimal to binary. So this is 1000.001 base 2. So this is the implicit normalization. So after the first bit I will place the fixed point. So my exponent is 2 की power 4. So what I will write, exponent is equal to 4 plus bias. Bias is 64. 4 plus 64 is equal to 68. My value is 68. So here in exponent part I will convert the binary number and I will write the binary number here 68. So in this exponent my 68 is here. You can also convert this 68 to the binary number. Okay, binary form. And after the decimal I have 0000001 and this number I have written here. So this is the floating point representation of different decimal number. I think that you understand. So this is very important. So now I will discuss about another question. This is very important. In 16-bit register with bias access 32 for 19.25 decimal number, find max and minimum and positive minimum floating point representation. This is asked in the previous year GATE exam. Your number is 19.25 base 10. This is your number and this is plus already. So what is the meaning of plus? This is access 32. He has given access 32. And this is the 16-bit register. So what is the meaning of 16-bit register? At first I will write 16-bit register. Okay. So my first bit is 0. Why? Because this is positive number. Done. After then this is the 16-bit. Now access 32. What is the meaning of access 32? This is 16-bit representation. The formula is 2 की power n minus 1 is equal to bias. Bias is 32. So this we can write 2 की power 5. Okay. So what is the meaning of this? N minus 1 is equal to 5. N minus 1 is equal to 5. So 5 plus 1 is equal to 6. What is the meaning of this? My exponent is 6 bit and 1 bit is sign. 6 plus 1 is equal to 7. 6 plus 1 is equal to 7 and total is 16 bit register. So 16 minus 7 is equal to 9. Okay, 16 minus 7 is equal to 9. So this is your 9 bit. This is your 9 bit. What is 9 bit? Your Mantis is 9 bit. I think that you understand. So I will write here total 6 bit. 1 bit, 2 bit, 3 bit, 4 bit, 5, 6. 1, 2, 3, 4, 5, 6. This is your exponent. Why it is 6 bit? Already we explained how to solve the problem. Now total number of Mantis is 9 bit. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one is the mantissa and this one is the exponent and this one is the your sign bit. So this is the floating point representation. How to find the length of exponent and this mantissa we discuss. Now we are discussing about the max and minimum. Now what he is asking, this 19.25, okay, whatever the number he is asking, 19.25 decimal number. At first write the decimal number here. This is your problem, you solve. 19.25 will convert to the binary form and after then you will write all the bits are here. Okay, I will not explain. I will discuss about the maximum and minimum. What is the meaning of maximum and what is the meaning of minimum? Now see here, I will discuss at first maximum and minimum. Now you can see here, I have a real line. This is my real line minus infinite to plus infinite. My real line from minus infinite to plus infinite. This is my 0. This is my 0. Okay. So what is the meaning of max? Max means plus infinite. Max means plus infinite. And what is the meaning of minus minimum? Minimum means minus infinite. Okay, so this is your minimum number and this is your maximum number first. So if you want a maximum number, what is the meaning of this? So in this exponent here, we are discussing about the minimum max. Minimum max means minimum. This, if you are going, this is minus 1, this is minus 2, up to so on, this is minus infinite. So whenever you are going to the left side, your number is minimum but max. Okay, minimum max. What is the meaning of this minimum max? Minimum but maximum, that is minus infinite. So minimum. Okay, so because of negativity I am writing plus 1. I think that you understand. And this is my exponent part, this is my exponent part, and this is my mantissa part. This is my mantissa part. If you want max number, what is the meaning of this bigger number? So you have to place all bits are in exponent is 1. Okay, how many bits are there? You place all 1, and you, because you want a maximum number. Here also, if you want a maximum number, you place all 1 in mantissa also. Okay, this is the meaning of minimum. Okay, you have to place all 1. So if you are placing all 1 means you are getting bigger number. Okay, now next same also real line example. So you want biggest number. So this is maximum number. So the first, if you want a maximum positive number, so positive means 0. Okay, means I am here, but I want a max number. Again I will push all value are in the exponent as well as in mantissa. All value are 1. All value are 1 here as well as here. So my number is bigger. My number is bigger. Now we are discussing about another point. This time we want maximum number. Okay, we want a maximum number, maximum positive number. This is not maximum positive number, minimum positive number. Minimum positive number. I want a positive number but minimum. So positive means this side, positive means this side, but minimum means very close to 0. Very close to 0. This is the minimum number. Very close, 0.00001 like this, na? But this is not possible because we are talking about either explicit representation or implicit representation. So if you are talking about the explicit representation, so I will write 0.1. After then whatever the bits I am writing. If you are talking about the implicit representation, then I will write 1 dot mantissa. Okay, so either I am writing 0 point mantissa or 1 point mantissa, explicit or implicit representation. I want a positive number is very big, so 1 dot m is not good because this is not bigger, this is smaller. 1 dot m, this is not. I want a minimum positive. I want a minimum positive. So 1 dot m is not minimum is 0 point m. 0 point m is the minimum. So 0.1 is the minimum. 0.1 is the minimum. You understand? Okay. So what is the meaning of this? I want a positive, so I will write 0. I want a minimum, so I will write all 0. Exponent is 0. Your exponent is 0 because I want it to be very small number. Mantissa I am writing 1.0000 because after this 0.1, after this how many 0 you can write 0. I want a minimum, very small. So this is very small. This is the minimum positive number they asked in GATE exam. You have to remember. Okay. Now we will discuss about other topic. So students, we are talking about 19.25 base 10. Okay. So at first I will convert the number to the binary form. Then we will discuss about something. Okay. So my number is 19.25. Okay. And base, similar question every time came in your GATE exam. Okay, base 10. So I will convert this number to the binary form. If you convert, you convert. Okay, you try to practice. I am writing directly 1 0 0 Okay, 1 0 0 1 1. You can check also. Maybe I am wrong. Okay, dot 0 1. Okay, this is your binary representation. Okay, now I got the number. Now I will write minimum either explicit or implicit representation. Let we are discussing the explicit. So what is the meaning of explicit? After 0 I will place the radix point and I will place all the bits. Okay, so my bits are 1 0 0 0 1 0 0 1 1 0 1. I think that you understand. So this is the meaning of explicit representation. Then I will write here exponent 2 की power. What is this? 1 2 3 4 5. I will write 5. I will write 5. So this is the meaning of explicit representation. Okay. Now after then what I will write next? What is my sign? My sign is equal to, what is my sign? Sign is equal to 0. My sign is equal to 0. Next I am writing my exponent. What is my exponent? My exponent is equal to 5 plus bias. What is the bias? Already we discussed about the bias is equal to 32. So 32 plus 5 is equal to 37. So now this 37 you will convert to the binary form. If you will convert it, you will get 1 0 1 0 0 1 0 0 1 0 1. Okay, you are getting this number. Okay, this is your exponent. Then we will convert this exponent to be done mantissa already here we have written. Okay, now I am writing the number in a correct form. Okay, so at first your sign bit is 0. Okay, at first I am writing your sign bit. Then I am writing your exponent is 1 0 0 1 1 0 1. This is your exponent, already we written. After then this is your exponent. After then I am writing your mantissa. What is mantissa? My mantissa is 1 0 0 1 1 0 1. This is my mantissa. Done. Once you complete your mantissa, all the parts, what you will do? After then what we are doing, I will take the 4 bit. Another 1 2 3 4 bit. I will take the 4 bit 1 2 3 4 bit. Okay, similarly I will take the 4 bit. There is nothing. I am writing 0 0 0 1. Okay. So now after then I will check what is my exact answer. 0 1 0 0 0 1 0 0, and after then 1 0 1 1 1 0 0 1 0 0 1 0 1 1, then 0 0 1 1 and 0 1 0 1. If you will check mantissa, one thing I have not written here also 0 0. After the mantissa, if I am not filling here, if I will write total, I will go the previous. Okay, I am placing here. I should place here. So what is my number? My number is equal to my mantissa. At first I am writing this number. Sorry, at first I am writing this number. What number? I am writing this 1 0 0 1 0 1. I am writing here 1 0 0 1 0 1 1 0 0 1 0 1. I have done. Okay. Next what I am writing, already we explained how to solve the problem. Okay. Now next my mantissa is 1 0 0 1 1 0 1 1 0 0 1 double 0 means 100 11 0 1 100 11 0 1 100 11 100. This is 100 11 0 1. 1001101. You can check also if I am wrong, maybe 1001101. If you are not able to see, you can see also. This is my Mantissa, 1001101. So I am writing here 1001101. After then you can see there is a 4-bit left. So I will write 0. After decimal I can place many 0, no problem. Done. So this is the representation of this floating point representation. I think that you understand. I am using this explicit this time. You can use also implicit, no problem. Now I am writing what I am writing now. See here, I am writing something different here now. So now the 4-bit, this 4-bit, and after then the 4-bit 1 2 3 4. Again after the 4-bit from here to here, 4-bit from here to here, where 4-bit from here to here, 1 2 3 4, 1 2 3 4, 4-bit from here to here, okay. Then after then 4-bit from here to here, okay. I am writing. So now what is this actually? What is this? What is this? And what is this? And what is this? Okay, we will discuss. Now see here, I am coming here. If you know the decimal, hexadecimal, okay, your first is representing 0, second is 1, this is 1 2 3 4. After 9 you will write A B C D E F G, okay. So now you will use this method and you will place the value here. So my first value, if you will check, if you will see 0100, what value we are getting actually. If you see here, my first value 0100, I am getting 4. I am getting 4. And second 1011, 1011, I am getting B. If you will check, I am getting B. And third 0011, 0011, I am getting 3. If you will see 0011, 3. And 0100, this is 4, already you know. So this is the base is 16 now. This is the floating point representation. The number, decimal number, we convert to the floating point representation. Then we convert to the hexadecimal form. Okay. Again, this hexadecimal to decimal you can also convert. Already we explained how. Okay. But you have to use this bias. What is the bias? Bias is axis 32. So we discuss how to represent the sign bit and how to declare total number of bits in exponent and total number of bits in the mantissa. We discuss. Now one by one we are going what is the actual range. We are discussing about the, we will not solve the question, we will discuss what is the range actually. Okay, we will go here, what is the maximum range and minimum range, we will discuss here.
Our mission is to help students achieve academic and professional success.
We will guide you step by step with high-quality learning resources and practical problem solving.
Hello students, okay, again we are solving some another question. So now here what he is asking, the 16-bit register of the following, the mantissa, okay, we are using the mantissa sign magnitude fraction, and exponent is the axis 64 form. So he is asking how many bits are used for the fractional mantissa. Okay, so this is 64 bias, and maximum minus value means you want maximum fractional value, so you have to write minus 64. Okay, so it means that this is minus 2 की power 6. This is minus 2 की power 6. 2 की power 6 is equal to, है ना, 64. Now I am writing minus 2 की power 7 minus 1. Already I told that 2 की power k minus 1. Okay, the formula. So now what is the meaning of this? This is the first is representing the sign bit. You want the bits fractional mantissa. Okay, so here I am writing 7 bits. Why I am writing 7 bits? Because of this reason, because of this formula already we discussed. 2 की power 7 minus 1. This 7 is representing the 7 bits. Mantissa, what is the mantissa? Mantissa is 8. Why? This is the question. Because in the question he has given, this is the 16-bit register. If you'll see in the question, he has given us, this is the 16-bit register. So total is the 16-bit register, and 1 is the sign bit, 7 is the exponent, remaining is the mantissa part. This is the meaning of this question. I think that you understand. Similarly, he is asking about again 16-bit register question. So what he is asking, the 16-bit register, what should be the expression for the decimal value? Okay, this question also same. He is asking the expression. He is asking the expression. He is asking the expression. Now see here, already we discussed about the expression last time. So minus 1 की power s. Why? Because this is a negative value. Okay. Second, 1 dot mantissa. We want the, actually why we are writing 1 dot mantissa? Okay, because this is the implicit normalization form. Okay, implicit normalization fractional, and 2 की power e minus bias. What is bias? Bias is minus 64. Okay, because this is the representation of the floating point. Okay, now second, what is the smallest and largest? Again we are discussing about the smallest and largest. Okay, now what the question he is asking, what is the largest number in base 10 that can be represented using the register? Same question. Already we told, if you want max number, okay, if you want max number, what you will write? If you want max number, what you will write? So if you want max number, now so in mantissa part you have to write all 1. Already we told, all 1. Okay, exponent, what is the meaning of exponent? Here I am writing 2 into e minus bias. What is e? E is 127. Why e is 127 here? Because you can see that 2 की power 7. 2 की power 7, already we told 2 की power 7. Actually what is this? 2 की power 7. 128 minus 1. Okay, so this is because of this e is equal to 127 and minus bias. So this is the max number, this is the maximum number. Okay, after then you can calculate, the dot will come from here to here, and after then your value will be minus. If you are coming to the right side, minus. Okay, power is minus. If you are going to the left side, power is increasing. And at last you can, this is a mathematical representation, you can solve the other. Okay, so after then you can calculate, this is your final answer. So what is the largest, how to find the largest and how to find the smallest, already we discussed. So here we will not waste the time. This question already we discussed. Again largest and smallest, again same question also you can see. So if you want a smallest number, what I told, you have to write all 0. Okay, in mantissa as well as in exponent. Okay, done. And if you want the second smallest, then you have to write the smallest. Okay, this is the mantissa part. Exponent is 0. Okay, smallest, and positive means 0. Okay, and you want a smallest positive means 0,00001 means converging to 0. Okay, this is a decimal part. Very small means at last you will write the 1. Okay, this is the second, because this is the second. If you want a smallest, all 0. If you want a smaller than bigger, so this is, what is the meaning of this? 0,0000001. Okay, very small. So why 1 is here? Because total bits are already we discussed about the length of the exponent and length of the mantissa. Okay, already we discussed. So no need to discuss here. So the last bit you have to write 1. Second last. Third last, again 1 1 1 you shift. If you want to find difference, you can easily, this is the mathematics, you can find the difference. We will not discuss. So we discuss about the how to find the length of this exponent as well as how to find the length of the mantissa. Okay, and there is a formula we discuss. So here we will not waste time. Now we will discuss about, actually you can see that for the representation there are some standard organization. Okay, the first standard organization is ANSI, means American National Standard Institution. They have given you this ASCII code 7 bits, and similarly the IBM, they have given you one standard, okay, 8 bit 4. And similarly, to represent the floating point representation, the IEEE, they have given you the standard, okay, standard floating point representation. So there are many different version came. So we are not discussing about here. Here we are discussing about this one, okay, because this is very important. So number first we are discussing about the binary. Okay, here we will not discuss. I will discuss here, okay, because wasting time is not good. So now here there are total number of many different representation. Number first is the binary 16. So this is the half precision. Second is the binary 32. This is the single precision. Third one is the binary 64. This is the double precision. Fourth one is the binary 128. This is a quadruple precision. And after then 256. This is the octuple precision. So now here question is significant bits, exponent bits and exponent bias. So there are some numbers and this is a representation, organization of bits, how to organize the bits in exponent as well as in mantissa. Okay, so this already we discussed. Where we are discussing about this one. So how to remember this one, because this is very important during your GATE exam or competitive exam. Okay, this number no need to remember. How? I will tell you. Actually there is a formula. Formula is, I am writing the formula here. 2 की power, you have to remember is 2 की power, already we discussed 2 की power n minus 1 minus 1. Okay, this is a formula. How to remember? Now see here. Suppose actually what is this? 16. This is the number first is 16. 16 means 2 की power 4. You know that. 16 means 2 की power 4. So 2 की power 4 minus 1. I am writing here. Suppose the number is 5. Exponent is 5. Okay, 5. So I will write 2 की power 5 minus 1. 2 की power 5 minus 1 is equal to 4. 2 की power 4. 2 जा 4 2 जा and 2 की power 4 is equal to 16. 16 minus 1. 16 minus, I am using another color. Another color is not coming. Okay, just minus 1 minus 1. Okay. So now if you will calculate 2 की power 5 minus 1 is equal to 2 की power 4. 2 की power 4 minus 1 is equal to 15. Very simple. Similarly for 8, now you write here n is equal to 8. 2 की power 8 minus 1. 2 की power, if you are not able to understand, I am writing here. I am writing here. I am writing here 2 की power 8. 2 की power 8 minus 1. Minus 1. Okay, listen here carefully. So 2 की power 8 minus 1 is 2 की power 7. 2 की power 7 is equal to 128. This is 128. 128 minus 1 is equal to 127. This number they have written here. Similarly, you can find these number easily by the help of the formula. So no need to remember these numbers. No need to remember these numbers. You have to remember only this 5, 8, 11, 15 and 19. And this number also easily you can understand. How? You can see your first number is 5. 5 plus 3. 5 plus 3 is equal to 8. 8 plus 3, 8, 9, 10, 11. 8 plus 3 is equal to 11. Okay. So at first you are adding 2 times 3. 5 plus 3, 5, 6, 7, 8. 8 plus 3, 8, 9, 10, 11. Now 11 plus 4 is equal to 15. 4 plus 1, 5. And 15 plus 4 is equal to 19. So at first we are adding 2 times 3. Then we are adding 2 times 4. Very easy to understand. So here you have to add 4 and here you have to add 3. I think that you understand. So no need to remember before the exam. Okay, this half precision, single precision, double precision, everything you can understand by the help of this formula. Okay, so we have given you one formula to remember. So in exam you will never forget. Now here there are many other representation. Now see here, this is the single precision. Single precision, what is the meaning of single precision? Now here I am writing m is equal to 23 bits, and here I am writing sign bits is 1 and exponent is equal to 8 bits. Actually what is this? I will tell you one thing. Now see here, I am writing significant bits. In the single precision, my significant bits is equal to 24. Okay, now see here, I am coming here. So you can see here, my 23 plus 1 is equal to 24. This is the significant bits, and remaining is the exponent form. So 23 plus 1 is equal to 24, 24 plus 8. Okay, so this is 24 representing the significant bits, and 8 is representing the exponent bits. Okay, and 8 is representing the exponent bits. So because of this 8, because of this exponent, I am writing 8 here. Done. So now this first 0 and 1 representing the sign bit. Okay, I can write 0 or 1. If I am writing 0 means plus, otherwise this is negative. Done. Now if all the exponent are 0 as well as all the mantissa is 0, it means that this is the smallest number. So either it is plus 0 or minus 0. Done. Second, if exponent is all are 1 means 255, maximum is 255, but mantissa is 0. Mantissa is 0 means this is the maximum number. What is the meaning of this? Is exponent all are 1 means, exponent all are 1 means, and here you are writing maximum value. What is the meaning of this? This value is the maximum. You are writing max means E is max. Okay, how many bits are there? Register, according to the length of the register, you are putting all the numbers here. So you are reaching to the maximum value. So it means that your means is exponent all are 1 means 255, and mantissa means suppose you have a number 1 dot, and after decimal there is no number. So in this condition your value is the plus infinite, maximum number. Third one, if the value of exponent is from 1 to 254 and your mantissa is any value, in this condition this is the implicit normal form, and this is already we discussed. Now this is very important, and if you remember only this table, next table is also same. So if E is equal to 0 and mantissa is not equal to 0, E is equal to 0 means exponent is all 0. Your E is 0 means exponent is 0 and mantissa is not equal to 0. This is a fractional form. That is very simple. Okay. And if E is equal to 255 means max, and mantissa is not equal to 0, this is the non-representation form. If you remember this one, so second also double precision also easily you can understand. This same, and this is also same, and here also this is also same, and here also this is also same. Only one difference. What is the one difference? Double precision, only this value you have to remember. So 52 plus 1 is equal to 53. 52 plus 1 is equal to 53. Now you can see significant bits double precision, this is the value is equal to 53. This value is equal to 53. So this 53 no need to remember, already we discussed how to remember it. Okay, significant bits, if you know only the exponent you can easily remember. So now this is already we discussed, so we will not discuss again and again. Double precision also same method. Okay, if you know the single precision, double precision you can easily understand. Now we are not wasting your time. Now we are solving one gate question. This is very important. What he is asking, the 30-bit register. Okay, and he is asking find the decimal value of the following 32 bits. So he has given you this number. So now I am writing the biased exponent 131. Why? Because this is the single precision format. In single precision format, what is the bias? Bias, you have to remember, in the single precision format. Now here bias exponent, how I got? If you calculate the value here, 1 0 0 0, okay, and 0 0 1 1. This value is 131. Because of this I have written here. Now bias is 127. How? Go here. Single precision. My bias is equal to, in single precision, my bias is equal to single precision. My bias is 127. You can see. Okay. So if my bias is 127 means what is the meaning of this? So I have written bias is equal to 127. You have to remember it, or easily you can understand by the help of our formula. So it means that I will find the value E minus bias. So 4 is the answer. So value is equal to, this is a representation, minus 1 ki power 1 because this is a negative number, a positive number. Okay, minus 1 ki power s, 1 point mantissa into 2 into e ki power 2 ki power e minus bias. Bias is 127, so the value is equal to this one, minus 1 ki power 0, 1.11. Why 1.11? Because your mantissa is 1 1, only 1 1. Mantissa is only 1 1 after then 0. So I am writing 1.11. 2 ki power e means 4. Already we discussed. So this is a binary form. Then you can find the decimal form. Okay. So now second question he is asking. And this is also gate question, 32 bits register, and he is asking find the decimal value for the following 32 bits. He has given you this question. Okay, now you can see all are 1 here again. If all are 1 means max, number first, all are 1 means max, but in mantissa there is some value. So this is not a max actually. Mantissa is not equal to 0. What is the meaning of this? You are coming here. So this is the non-representation form of floating point. Now next question, consider a 64-bit register. Now bit is 64-bit register, and find the decimal value for the following 64 bits. So first sign is indicating this is a negative, and after then this is the exponent form, and this is a mantissa form. Okay, now see here, biased exponent is equal to 1027. Why? If you know the double precision format, the bias is equal to 1023. Okay, 1023 means 2 ki power 10 minus 1. 2 ki power 10 minus 1 minus 2 ki power 10 minus 1 2 ki power 10 minus 1. So 2 ki power 10 is equal to 1024 minus 1. So 1023. So this is double precision form 1023, and your bias exponent is this. Why? Because if you convert this number, what number? This 1 0 0 0 0 0 0, then after then 0 0 1 1. If you convert this number, you will get 1027. From here I am writing. Okay, if you are not able to understand, you can see here I am writing here. So this number 10 1 0 0 0 0 0 0 0 0 1 1. So this number is 1027. So I will find the exponent E is equal to E is equal to 1027 minus bias. Bias is equal to 1023. My value is equal to 4. So my representation of double precision form is minus 1. This is also same floating point representation, minus 1 ki power s, 1 dot mantissa, 2 into e ki power e minus bias. Bias is equal to 1023. So I am writing E is equal to 1024 minus bias is equal to 2 ki power 4. So your value is equal to minus 1 ki power 1 dot mantissa. What is mantissa? 11011. Okay, this value 11011 11011 into 2 ki power 4. Now you can calculate. Okay, and you can converts to the decimal form. Already we discussed. Will not waste the time here. Now second question he is asking. What he is asking? He has given you a number and he is asking what is this actually. So I already told, if all are 1 means max, but mantissa is all are 0 means 100% max. So this is plus infinite. Why plus infinite? Because your first sign bit is 0. Your first sign bit is 0. Okay, because of this is plus. If it is 1, then this is minus infinite. Now second question, what he is asking? He is asking represent the 116 base 10 in single and double precision format. Very simple. He has given you 116. At first I will convert this 116 to the binary form. Done. This is first I done. Now after then I will try to place the decimal. So I am writing 1 dot 110100, and in this condition I am writing this 2 ki power 6 because forcefully I have written the fixed point, because my representation is 1 dot m. Okay, 1 dot mantissa. So because there is no decimal, I am placing the decimal forcefully. So because of this 2 की power 6, whenever the dot means decimal is your decimal or fractional point is coming from right to left, then you have to increase the exponent. Okay, 2 की power 6, because it is placing 2 की power 6. If you are not able to see, I can also show you. Total numbers are here 1, 2, 3, 4, 5, 6. Okay, after 6 I am placing this dot, so 2 की power 6. Now see here, my first value representing the 0 means positive number. Second, because 116 is the positive number. Second, this is the exponent form. So exponent, now see here, this is a single precision. In the single precision, your bias is equal to 127 and E is equal to 6. So 6 plus bias is equal to 133. This 133 I will convert to binary form. The value is this. You can calculate also. This is 133. And after then, whatever the value, this value is the mantissa. What is the mantissa? This is mantissa. 110100. 110100. And what is the length of this mantissa? Already we discussed. Here we will not waste the time. Okay. Similarly, for the double precision, same formula. What I am writing? I am writing 6 plus bias. Bias is 1023. So this value I will convert to binary form, and I have written here. Okay. And you can see that here the size is changing. Exponent size is also changing, as well as the mantissa size also changing, because this is a double precision form. And what is the length? Already we discussed. Go to the previous topic. Okay. Now again another question. What he is asking, this question already we discussed. He is asking actually what is the fractional form. Fractional form already we discussed. Fractional means E is equal to 0 and mantissa is not equal to 0. This is a fractional representation. Okay. Now next, what he is asking? He is asking floating point representation using the fractional form of IEEE 754 single precision format. So now he is asking what is the fractional form. So fractional form, here you can see we are writing something actually. The question is coming, why we are writing this minus 126. Now see here, if you are writing, I already told, you are writing the fractional form, means I am not writing the number, means I am not writing 1.m. I want only fractional. So in this condition I will use the implicit form. So 0.m. I am using 0.m because I do not want the I want a fractional, pure fractional. So pure fractional means 0.m. So in this condition it must be 127 actually, but I am writing minus 126 because of this reason. Okay, done first. Okay, so minus 1 की power s 0.m 2 की power minus 126. I think that you understand. So now this is a single precision format. In the single precision format already we discussed, your exponent is 8 bit and your mantissa is 23 bit, 23 and 1 is significant bit. 23 plus 1 is equal to 24 is the significant bits. Okay, 8 is the exponent bits. Now we are writing the smallest fraction. Already told, smallest means all are 0. What is the meaning of this? 0.0000, everything is 0. But we want a smallest. So at last, smallest. 0 is the smallest, okay. 0 is the smallest. But we want the smallest fraction. Okay. 0 is not a fraction. Number, you have to remember. 0 is not a fraction. We want a smallest fraction. What is the meaning of this? At last, 0.00000 at last 1. So this is the smallest fraction. Okay. After 0, there are many 0. And at last 1 means this is the smallest fraction. So I am writing 1 at last and 2 into 2 की power minus 126. If you will calculate, you will get the exact answer, that is 2 की power minus 149. 2 की power minus 149. This is the smallest fraction. Similarly, you can find the largest fraction. Largest means all are 1. And other is same. Okay, largest fraction. Okay, other is same, and similarly you can find the largest fraction and other fraction. So already we discussed about that, how to find the smallest and largest. Okay, so no need to discuss one by one. And if you have any argument, you can see also here one thing. Actually this is our standard representation of the floating point minus 1 की power s into, okay, 1 dot mantissa, okay, into and 2 की power e minus bias is 127 for the single precision. So e, if exponent is 0 means this is a fractional, exponent is 0 means this is a fractional. Why? Because 2 की power minus 127. If 2 की power is positive means this is not a fraction. I want a fraction means 2 की power negative. I think that you understand. So in the previous question we have written here 126 because I am not writing 1, I am writing 0. I am writing 0. I think that you understand. So now we will come to the next topic. And this question already we discussed, and this question came in your GATE exam. He asked find the value of a minus b, implicit normal form and fractional form. Okay, already we discussed about the smallest positive number and largest number. Already we discussed, and you have to subtract the smallest number, largest number, then subtract. Now student, so we are solving the 2026 GATE question. Okay, so here what he has asked, he has given you one x is equal to something and y is equal to something, and he is asking what is the value of x plus y. Same question they are asking every time. Sometimes they are asking x into y, okay, sometimes they are asking x minus y, sometimes they are asking x upon y. So every time the questions is same, you have to understand only one question. So this question we are trying to explain the value of x. So this is in hexadecimal form. Okay, at first we are explaining something. So I will show you something. Now see here, here we have written the same value, okay, 35C000. We are explaining only one. So this is the hexadecimal table. Already we explained how to draw it, okay. So the value of 3 is we have written here, the value of 5 we have written here, and the value of C we have written here. So now this value 3 you will write here, okay. Then after then the 5 you will write here. Then after then this value C will write here, and remaining all are 0. Done? You understand? You have to learn only one question. If you understand one question, so second question easily you can understand. So now next I explain everything. Now see here. So what is the meaning of this? This is your formula. Your formula is minus 1 की power s, okay, into I am using the mantissa. So implicit form. Here I am using the implicit form 1.m into 2 की power e minus bias. What is bias? This is a single precision. In single precision we are taking 127. Okay, this is the formula. Okay, same formula I have written here. This is the floating point representation. Now, so already we explained that in the floating point representation, single precision, what is the length of this exponent? This is a 8-bit and this is 23-bit and 1 bit for the sign. Done? So now this x we have written in this hexadecimal form. So these 23 represent the mantissa and 8-bit represent, after writing this value x, already we told you have to write in this value, you have to write in binary form. Already we explained just after writing, and you have to write the first bit is indicating the sign bit, and after then the 8-bit representing the exponent, and after then the remaining there is only one bit actually, only one bit. This is representing the mantissa. After then you can add many zero. Okay, but the length is 23, so we have added total 22 zero. Done. So now at first we will convert this exponent. This exponent I will convert to the binary number. This is the 107. Okay. So now I am writing this in my in my formula, -1 की power 0. Why 0? Because this is the positive number. This number is the positive number x. So -1 की power 0 into 1.1. 1 point mantissa. Mantissa is only 1. After then all are 0. Okay. 1.1 into 2 e की power means 107 minus bias. Bias is 127. The overall value is this. So you have to understand only one. If you understand x, so y also you can implement very easy form. Okay. Now you can see also we implemented y. You have to understand only one question. Same y, this is a hexadecimal form. I convert this 3 to the binary form, this 4 to the binary form, this 8 to the binary form, and remaining there are 5 0, and after then we add some extra 0 because after decimal I can add many 0, infinite 0 I can add. Okay, so no meaning. This is 2.3. Okay, so same thing also we are adding all 0. Okay, because we want total 23 bit. This is the mantissa, and exponent is the 8 bit and 1 bit is the sign. Okay, now I am taking this exponent. So this exponent I am taking and I will convert this exponent to the binary. Already we explained how. Okay, now this is my formula. What is my formula? -1 की power s. S means 0 because this is a positive number. After then 1 dot mantissa. Mantissa is only 0 1 because after then all are 0. No meaning. After decimal even there are infinite 0. No meaning. Okay, so 1 dot 0.1 into 2 e. What is e? E is equal to 105 exponent. Minus bias is 127 because this is a single precision. In single precision 127 is the bias. So after then I will write in a correct method, and overall this is also so we have to add, we have to subtract, we have to divide. Okay, sometimes they give x upon y, sometimes they give x into y, sometimes they give x minus y. In every year gate question you can see also. So I will write in same power, so we can divide, easily we can multiply, easily we can subtract. So now you can see that x plus y is equal to, easily we can add. Now we have to add 1.1 plus 0.0101. So easily we can add. This is the final answer. I think that you understand. If you understand, you can solve any question. Now at last what I will do, I will convert the question to the same hexadecimal number because he is asking the output is in hexadecimal number. So my sign bit is 0 because my number is positive. So bias is equal to your value. It was -20. You can check, and this is a bias. You subtract. Now I am adding 127. So total value is equal to 107. This value I will write in binary form, and your mantissa is this. You can check also here. What is your mantissa here? Okay, this is your output. This is your output. I am taking the value from here. This is my z. My z is equal to 1.1101 into 2 की power 20. So my exponent is 2 की power 20 means 20, and dot 1101 is the mantissa. So same I am writing also here. So my 20 is the exponent. I am adding the bias, and this is my mantissa 1101. After then I am adding total 23 because the length of mantissa is 23 bit. So I am adding extra 0. So at last what I will write everything here. Okay, the sign bit, exponent, then after the mantissa, then I will convert this is to the hexadecimal form. This is the final answer. If you understand only this question, you can solve any question in the world. Okay, now I am going another question. This question I will not solve. Why? Because already we solved the previous multiple time the same question. So he is asking -14.25. So this time your value is -1 की power 1 because this is negative. Okay, into mantissa, 1 dot mantissa. How to find mantissa? Convert this 14 to the binary, convert this 25 to the binary. And what is the this is also single precision, so you will take the bias is equal to 127. After then you have to add some 0. okay, and into 2e. What is e? You will find e minus bias is equal to 127. Okay, this is your final answer. Same method you have to apply right here and you will get the exact answer. At last you will convert to the again hexadecimal form. Okay, now next I am solving next question. I will see this question also similar. I will not solve here, I will not waste the time. So the decimal value of 0.5 in IEEE single precision form, this is also very simple. Okay, so now you have to convert this 0.5 to the single precision form. Okay, you can solve this question. If you understand only one question, you can solve any question in the world. This question also we explain about the smallest number, biggest number, hexadecimal, everything. This is your task to solve the problem. Okay, pause the video and try to solve and tell me what is the correct answer. We already discussed about the smallest number and the decimal fractional number. Okay, so now another question. In another question, what he is asking, this is gate 2022. Okay, he is asking in 2 complement addition, the overflow. He is asking about the overflow. This is also very simple. Already we discussed about the overflow. Okay, so you try to solve the question. I will solve some important question. This question I will solve because multiple times he is asking about the overflow. Actually, what is the meaning of overflow? We will discuss. So he has given us here first value n1 is equal to, he has given us 1011 number first. Second, he has given you n2 is equal to 1101. Okay, this is he has given. And what is the value of n3? He has given 1010. Okay, so 3 value he has given, and n4 also he has given. n4 is equal to 1001. Now let us, we will check actually what is the value. Okay, this is 1011, and already we explained. If you will go to our previous the previous lecture, okay, here already we explained. Now you can see here what is the meaning of my n1 1011. n1 1011. Where is 1011? 1011 1011 1011 is this. Sorry. So 1011. We have to check 1011. Something wrong. Wait 1 minute. Okay, this one. Okay, so here what he is asking, he is asking what is 1011. 1011, 1 means a negative. Okay, I already told in 4 bit the first bit represent the sign and the 3 bit represent the this one magnitude. Okay, suppose I have written here 0001. So 0, I am writing here 001. And this 0 indicating this is plus, and what is the value? This is 1 actually. You can see this is 1. So this is 1, this is plus 1. If I want minus 1, what I will write? This is minus, so I will write here 1, nothing. And remaining 3 bit, I will write same value 001. So this is actually minus 1. I think that you understand. Minus 1 because of this sign bit. This is the, what is this? This is the this is the magnitude, this is the magnitude, and this is the sign bit. Okay, now see here, this is 1011. 1011 is the 1011 is the this one 1011. Okay, sorry, here I should check here. Actually we have written 2 complement here. This is not hexadecimal. We are talking about the 2 complement. Already we discussed 2 complement. Okay, I will come here. So what he is asking, 2 complement. The question is 2 complement. So where, what is 1011? 1011. 1011 is the 5 number first. Second, he is asking n2 is equal to 1101. Where is 1101? 1101 is minus 3. You have to write in your copy. Third, what he is asking, 1010. 1010. Already we explained how to find the value. This is minus 6. And n4 he is asking 1001. 1001. Where is 1001? This is minus 7. Okay, this topic already we discussed. You have to write in your copy. Now we are going to our question. What is the question he is asking us? The question he is asking, the video is very long. If you will cover the lecture, then automatically you will get 3 marks in your GATE exam, 100% guaranteed. Okay, so you have to revise the video multiple times. You should try to solve the questions so easily you can crack the exam. Okay, you can get good marks. So now you can see my -5, your first value 1011, second is -3 if you have written in your notebook, and -6, this is -7. So how to find it already we discussed. Now you can see my n1 is -5. You can see minus range already, this also we explain. What is the range actually? I told my range is equal to -2 की power n minus 1 to 2 plus 2 की power n minus 1 minus 1. So if your value n is equal to 4, what is the meaning of this? Minus 2 की power 4 minus 1, okay, 2, this is 2 की power 4 minus 1 minus 1. So you can see this value is equal to -8 to +7. Already we saw also. Okay, so range is -8 to +7. If you are adding -5 -3, this is -8. Okay, I am inside the range. -3 -6 is equal to 9. This is overflow. This is the meaning of overflow. This is the best way to find it. Okay, -6 -7, this is +1. I am inside the range. -7 -5 -7 is equal to -12. This is out of range. This is the meaning of overflow. Okay, now next question. Here also I will not solve the question, is very simple. He has given you one hexadecimal number and he is asking what is the decimal representation. Already we discussed in 32-bit single precision. Every time he is asking the same question. And if you want, you can also solve this number. We have written in a hexadecimal form. Okay, you write in a hexadecimal form, and after then hexadecimal to binary form. I have written here hexadecimal to binary form. Here you can see there is a total number of 23 bit, and here total number of 8 bit, and here is 1 bit. So this is negative because 1 is coming at first, so it means that this is the negative number. And after then 1011, this is the exponent. So I will try to solve this value. This is actually 132 if you will solve it in decimal. So I have written 2 into 132 minus 127. So bias is equal to 127. After then 1 dot mantissa. What is mantissa? Mantissa is this one, 111 only, 0001. So this value I have written here. After then easily you can find the solution. Okay, I am not writing here the solution. You can solve very easily. Okay, 132 minus 127 is equal to 5, and so this is 2 की power 5 minus 1.111001. Okay, so now you can write in a systematic order. So what I did, this 2 की power 5 I multiply here, so I got the value here. After then I can convert this number to the binary form, so the value will be minus 60.25. So I think that you understand. You have to solve only one question. I already told, every time he is asking same question. He has given you x is equal to this and y is equal to this. This time he is not asking the hexadecimal. He has given the decimal. Already he has written this is the binary representation number. So x and y is the binary representation number. Now he is asking what is the correct out of this. He is asking. Very very simple. Okay. You can see if you want, I will also explain. So this is my range. My range is this. 8-bit magnitude range is equal to this. Already we told. So 8-bit, this is 8-bit, not 4-bit. In place of n, I am writing 8. In place of n, I am writing 8 in my formula. Okay. This is a sign magnitude. This is not a I explain the sign bit, 1 complement and 2 complement. The formula in sign bit is this. Okay, and the formula in 2 complement is 2 की power n minus 1. Again I am writing minus 2 की power n minus 1 minus 1. This is plus. This is the formula for the range for the 2 complement. Only this difference I have to write here -1. Okay, in 1 magnitude and sign magnitude, only this one. This difference only. If you remove this one, then after then this is the 2 complement. So now I will place the value n is equal to 8. Then after then I am getting my range is equal to -1272 to +127. This x I convert to the binary decimal form. This y I convert to the decimal form. After then you can add the value. If it is inside, you will say this is not overflow. If it is outside, you will say this is the overflow. Already we explained. Okay, so same question every time they are asking in every exam. This is very, very simple. Now same question also you can see 2025. What he is asking? The number -6. Already we solved the question. 1010 in 4-bit 2 complement representation. Which of the following is the correct answer? Represent to the -6. So this question already we explained. Again we will not explain. Okay, and you can see also this x is equal to this, convert to binary, y is equal to this, convert to binary, z is equal to this, convert to binary. And what he is asking? He is asking which one is the correct. Very, very simple also. This is also very simple. Convert x, y, z in a standard form, in decimal number, or you can write in the binary form, and after then you can check. Already we explained, so I will not waste my time. And now next question, what he is asking? Here he is asking, this is very, very good question. So the number is 2 to 4. In the class also we told base is important. So what is the meaning of here? So what you will write? 4 into, what is base? Base is 5 ki power 0. 5 ki power 0 plus, and this second is 2 into 5 ki power 1 plus 2 into 5 ki power 2, 5 ki power 2. If you will solve the value, this is 64 actually. Okay, decimal 64. At first convert the number 2 to 4. This he has given in radix 5. Okay, I will convert in decimal form. The decimal form is 64. So your first answer is correct. This is a decimal representation. Okay, for the radix 10 done. So now second he is asking which one is other correct. Now you can see this number. What I will write? I will write this 0 into base is 8 ki power 0. Okay, then I will write plus 0 into 8 ki power 1, base is 1. Then I will write 1 into 8 ki power 2, 8 is 64. So this is also correct answer. Similarly you can find here base is equal to 16, base is equal to 7. So in exam he can give you any base or radix point. Okay, this question multiple time came in GATE exam as well as NET exam, also in your semester exam. Same question also 2023. What he has asked? This question also very simple. He is asking P into Q. Already I told. Every time he is giving you the value either X or P or Q. Now this time he is asking P into Q. Very, very simple question. We will not try to explain because already we explained x minus y. Same you can write also x upon y. Same you can also write x into y. Okay, he can give you any question. Okay, all the questions are same. So now another question, what he is asking? He has given you 3 value A, B, C, and this is a 32-bit. This is a 32-bit IEEE 754 single precision. Single precision means this is bias is equal to 127. Bias is equal to 127. So this value you will convert, this value you will convert, this value you will convert. Already we explained. Now he is asking which one is the false. Very, very simple question. Okay, these questions you have to practice. Okay, so this is not our task. Next 2024 question also you can see, and here he is asking the IEEE 754 standard form single precision. This also we already discussed. The first one representing the sign bit, second 8-bit representing the exponent, and after that remaining 23 representing the mantissa. So he is asking the largest number. Already we discussed about the largest number and the fractional number and the second largest number, minimum, and if you want a maximum number, already we told for the maximum all the mantissa are 1, and for the exponent this value. Okay, so such type of many questions we already discussed. So I think that you understand. Try to solve more questions. We have added many questions. You have to understand only one question. If you understand one question, you can solve any question in your exam. Okay, so your success is totally depend on practice, not one night fight. Okay, thank you so much. I think that you understand.
Join our learning community and start your journey towards success.
Please subscribe to the channel and press the bell icon to receive.
Thank you for watching. See you in the next class.